Hey guys, welcome to the notes for graphing systems. We are in Unit 5. Our essential question is, what are the different types of solutions and what do they look like on a graph? All right, so previously we learned how to set up systems, which is where we're given a word problem and we're given a situation and we're asked to set up equations or a system. So again, like I mentioned, systems are more than one equation. So if we have two equations, we call that a system of equations. All right, so when we have equations and when we graph them, we're going to have three different types of solutions. Back in Unit 3 and Unit 4, we only had one equation, so when we would graph on a line, we would only have one line, right? But now we're going to have two different lines. So I'm going to talk about the three types of solutions you may have. The first type of solution you may have is, let's say I graph one of my lines, and one of them looks like this, and then the other one looks like this, right? So let's say I have two lines, and they cross each other at one point, so they have an intersection. That intersection is going to be a solution. So for the first graph, I would have one solution. Okay, and that's when my lines are crossing each other at only one point. The second type of solution, let's talk about it real quick. I want you to imagine two straight lines in your head. Okay, I want you to imagine two straight lines, and I want you to think, is it possible for these two lines to cross only twice? No, right? You can't have two lines and only cross twice. You'd have to bend the line, right? So if I had two straight lines, I can't have them cross twice. So another solution I could have is if, well, I have one of my lines here and the other line here. These would have no solution. There is no intersection here. And lines that don't cross are also known as parallel lines. So I'm using some knowledge back from Unit 4 here. So we're talking about parallel lines. If they have the same slope, they're not going to intersect, which means they're going to have no solution. They can't cross each other. All right, the last type of solution, maybe you can guess it already, it's going to be the infinitely many solutions. And you're like, well, what does that look like? Well, if I graph one of my lines, let's say I graph a line that looks like this. Actually, let's draw a straighter line here, okay? Okay, so I have a line that looks like this. Infinitely many solutions would mean that if I were to graph another line, it would lie right on top of it. And it would be the exact same line. So these lines end up being the exact same. So this would be infinitely many solutions. Yes, that is quite long, so I am okay if you want to abbreviate to IMS. And this only happens, or infinitely many solutions only happens if they're the same line. So they have the exact same y-intercept, the same slope. So if they have the same slope and same y-intercept, they're going to be the same line. When you graph it, it's exactly the same thing. So that's infinitely many solutions. So again, three types. You can have one solution, no solutions, or infinitely many solutions. And we've seen these types of things before already when we were just graphing regular number lines. All right, so number one, y equals 2 minus 1/2 x, and y equals 3x minus 5. So here I'm given two equations, and I need to graph them in order to find their solution. So the whole idea about systems of equations is that we want to find the solution, or the solutions that it may contain, right? So here, since I have two different equations, I'm going to graph them as two different colors. So the first equation I'm going to graph in blue. And the easiest form for me is obviously going to be slope-intercept, or y equals mx plus b. And these two lines are already in y equals mx plus b form, so that's pretty good for me. So you want to identify your slope and your y-intercept. So the slope for the first line here is going to be negative 1/2, okay? And our y-intercept is going to be positive 2. So remember, your slope is attached to the x because it's mx. So I'm going to go ahead and graph this line first. You want to start with the y-intercept of positive 2. Okay, and then you're going to have a slope of negative 1/2. So you will go down 1 and then to the right 2. Down 1 to the right 2. Now I know normally I ask you to only graph 3 points. However, sometimes it's possible for our lines to intersect on the edge of our graph. So I would go as many points as you can so that you can get that intersection in. So you could do as many points as you can fit onto that graph, not just 3. Okay, and make sure you draw arrows because that line doesn't ever stop, right? We're just picking 5 points to plot. All right, so that is my first line. The second line I'm going to graph is y equals 3x minus 5. The slope here is positive 3, but we want it as a fraction, so it's going to be 3/1. And then our y-intercept is going to be negative 5. So we've had lots of practice graphing before, so if we're having struggles here, then you need to come into tutoring. All right, so our y-intercept is -5, so 1, 2, 3, 4, 5, and our slope is +3/1, so it's going to be a positive line, up 3 to the right 1, up 3 to the right 1, up 3 to the right 1. So again, you want to go as much as you can through all of your graphs so that you can fit all of it in there, because sometimes it is on the edge. Now, the point where they intersect is going to be the solution. So they intersect right here at this green point. So the solution of this graph is going to be 2, 1. It's the point 2, 1. That's it. You're pretty much just graphing the lines and then finding their solution. All right, moving on. Number 2. We have x equals 4 and x minus 2y equals -6. So the first graph I'm going to graph in blue, or first line I'm going to graph in blue. Now this is just a letter and a number, which is going to indicate to me that I have either a vertical line or a horizontal line. But because this is x equals 4, I know this is going to be on my x-axis, so I'm going to go to the x-axis, and I know I'm going to be at +4. So 1, 2, 3, 4. Now I know this is vertical because it's x equals, so we would follow tick marks, so you would have a straight up and down line at +4. Make this line a little bit longer. Okay. All right, so I've graphed one of the lines, so that one was pretty good. Okay, now I have x minus 2y equals -6. Well, this is not in slope-intercept form, so I'm going to go ahead and move it into slope-intercept form, which is getting y by itself. So the first thing I'm going to do is I'm going to subtract x on both sides of my equation. -2y equals -6 minus x. And then the next step you would do here is you want to divide everything by -2 because you want that y by itself. Divide this by -2, that by -2, and this by -2. -2 divided by -2 cancels, and I get y. -6 divided by -2 is +3. And then the mistake that we commonly do is that we forget that there are two negatives here and here. So -1, right, there's technically a 1 there. -1 divided by -2 is going to be +1/2x. So this is my red line. So I've now converted from standard form to slope-intercept form. My slope here is +1/2, and my y-intercept is 3. So I'm going to start on my graph at +3, and I'm going to use my slope of 1/2. So up 1, and then to the right 2. Up 1 to the right 2, and then I'm going to keep going on my graph. Okay, so hopefully that you see that it does intersect our other line at a point, and that point is right here, my green. So again, when we're graphing equations, we're looking for the solution, right? So there's 3 types. So in this case, again, 1 type. The solution would be the point 4, 5. So solution 4, 5. Yes, you have to write it as a point. All right, moving on. Number 3, 3x minus y equals 0, and x plus 2/3 equals 1/3 y. Okay, so let's do this one line at a time. So let's go ahead and do the first one over here. Well, we want y by itself. And there are actually 2 ways to do this. And so I'll show you both ways because sometimes some people think of the easier way. So 3x minus y equals 0, 3x minus y equals 0. So I'm going to go on the left, and I'm going to do the way that you would typically do. You want to get y by itself, so first thing you do is you subtract 3x on both sides. -y equals 0 minus 3x, which is just -3x. And then the next thing you would do is you want y by itself, so you divide everything by -1. So -1 divided by -1 is 1, so it cancels. -3 divided by -1 is +3, and so we have y equals 3x. So that was the long way. The easier way is if I have 3x minus y equals 0, I really could just add y to both sides. So then I have 3x equals y, right? Because 0 plus y is y. So again, there's 2 ways to do this. There's a longer way and a shorter way, but they're the same. You're going to get the same answer regardless. So I don't really care which way you do, whatever works for you best. I don't really care. I'm not going to judge there. All right, so let's go ahead and identify our slope for this blue one. Our slope is going to be +3/1 because it's attached to our x, and our y-intercept here is going to be 0. Okay, so I have a slope y-intercept of 0 and a slope of positive 3 over 1. So I rise 3 and I run positive 1. Rise 3, run 1. I'm going to do the same thing down here. I'm going to draw my line. All right, now I'm going to do my other line. I'm going to do that one in red. I'm going to go ahead and move this, actually. Okay, so I have x plus 2/3 equals 1/3 y. And you're like, whoa, that's a lot of fractions. I agree, lots of fractions. Your goal here is still trying to get y by itself. You want to be able to get it into slope-intercept form, or y equals mx plus b. And it's kind of backwards, but y is over here, and it's almost by itself, except there's a 1/3 attached. And you're like, well, I can divide everything by 1/3. That's going to be kind of gross. But we know a trick to get rid of fractions, right? You want to multiply by the least common multiple, or the least common denominator. So I'm going to multiply both sides by the least common denominator, or least common multiple, which is going to be 3. So you have to multiply everything by 3. So anything you do to one side, you have to do it to the other side. So if I do 3 times 1/3 y, I'm going to end up with just 1y, or y. Okay, because 1/3 times 3 is 1. Then I do 3 times x, which is going to be 3x, and then 3 times 2/3, which is going to be positive 2. So now I have 3x plus y equals, or 3x plus 2 equals y, and this is in slope-intercept form already. So let's go ahead and identify our slope and our y-intercept. Our slope here is positive 3 over 1, or positive 3, and our y-intercept here is positive 2. So I'm going to start my graph here. So I have positive 2 as my y-intercept. Remember, it's on the y-axis. Sometimes we graph on the x-axis on accident. Then we go up 3 over 1, and we go down 3 over 1, down 3 over 1. So when I graph this, I notice that I can't see an intersection on my graph. So I'm like, well, maybe they're parallel. And to double check myself, I can look at their slopes. So the slope of the blue line was 3 over 1. And the slope of the red line was also 3 over 1. Because these are the same slopes, they're never going to intersect, which means we're going to have no solution. They're never going to cross, so they can't intersect, so no solution. There is no point where they cross just once, right? All right, last one. Y equals 2x minus 3, and 4x equals 2y plus 6. So the first graph, or the first line, is already in slope-intercept form, so that's pretty nice. Our slope here is going to be positive 2, or positive 2 over 1. And our y-intercept here is negative 3. So we have a y-intercept of negative 3. And you want to use your slope of up to the right one, up to the right one. It's positive, so I'm going to go in the positive direction. And I'm going to keep graphing just in case the solution's on the edge somewhere. All right, this other graph I'm going to do in red. Now I want to get y by itself because right now it's in some weird funky form. So I notice that my 2y is on this side, on the right side. So I'm going to go ahead and move the 6 over by subtracting it from both sides. 4x minus 6 equals 2y. And then I'm going to divide everything by positive 2. So divide this by 2, this by 2, that by 2. It's kind of backwards than what we're normally used to. So 4x divided by 2 is going to be positive 2x. And then negative 6 divided by 2 is going to be negative 3. So this is my red line. My slope is going to be positive 2 over 1, and my y-intercept is negative 3. So I'm going to graph negative 3, and then I have a slope of up 2 to the right one, up 2 to the right one. As I'm using my slope, I notice that it's landing on every single point that I had previously. So these end up being the same line. If you notice, your slope and your y-intercept are exactly the same. So because everything's exactly the same, it's intersecting an infinite amount of times, right? It's crossing each other infinitely amount of times. It's not just one time, it's not just 2 times, it's an infinite amount. So this is infinitely many solutions. Or IMS if you don't write out infinitely many solutions. All right, so that's graphing equations. Now we're going to move on to graphing inequalities. So we have had a lot of practice graphing equations and graphing inequalities. However, we haven't done them at the same time, or 2 at the same time, I might say. So let's go ahead and review a little bit about inequalities. So there are 2 types of things I have to ask myself when I'm talking about inequalities. Do I put a solid line or a dotted line or a dashed line, whatever you want to call, or also, do you shade above or below? So let's talk about our inequality signs. So if I have a less than or equal to and a greater than or equal to, that's going to be a solid line when I graph, right? If I have a solid line on my inequalities, I have a solid line when I graph. If I have a less than or a greater than without the equal to symbol, then that's going to be a dashed line or a dotted line. Okay, and then if you have a greater than symbol, so if it's greater than, you shade above. If it's less than, you shade below. Right? So if someone's less than you, you shade below. Right? They're below you. So you think, oh, less than me, shade below. So those are the two things that you need to think about as you're doing inequalities. So when we have a system of inequalities, the solution is not a single point, right? We're shading, right? There's lots of shading going on. So instead, we actually have a region of points in a shaded area that are considered the solutions. So for example, and this is just a random example, so it has nothing to do with the problem. I'm trying to show you visually. So let's say, for example, you have one of your lines, and it looks like this. So you have a greater than or equal to, and it's greater than, so then you shade above. And so you're like, okay, I shade above. And then you have another line where you have a less than or equal to, so you have a dashed line, because it's not less than or equal to, just less than. You have a less than symbol. And then it says to shade below, so you know you have to shade below. So you're like, well, there's a lot of shading going on. The parts where the solutions are located, the region, would be where those two colors overlap. So where these two colors overlap is going to be where my solutions are. So where this orange part is, that's where all my solutions. So any point in that region is a solution. But any point on the outside of this orange spot, so all of this is considered a non-solution. So if it's in the double overlapping, those are where the solutions are. If it's anywhere else, those are non-solutions. So if you want to make a note to yourself, so we'll go ahead and make a note up here. Solutions are in the overlapping area. Because we're used to just having a solution in the shaded area. However, this time it has to be the overlapped shade area. So let's go ahead and graph. We're going to graph the first one over here. The first equation is y is greater than or equal to 1 minus x. This is already in slope-intercept form, or y and mx plus b, so I don't have to move it. Our slope here is going to be negative 1 over 1, right? That's tricky because there's a negative 1 in front of my x, and then you put that over 1 so that you can have a rise and a run. Our y-intercept is going to be positive 1. So I'm going to graph. I have positive 1 as my y-intercept, okay? And then I'm going to have a slope of negative 1 over 1. So I'm going to go down 1 to the right 1, down 1 to the right 1, down right. And you want to go as many as you can because you want your shaded region to be as full as possible. And this is going to be a solid line because it is an equal to symbol. And then you also have to shade for this. So because it's y is greater than or equal to, then I'm going to shade above because it's greater than. So I'm going to shade all up here. Okay. All right, so now we have the next equation, which is, inequality. 5x minus 2y is less than 6. Well, y is not by itself, and we don't know how to graph an inequality unless it's in slope-intercept form. So I'm going to go ahead and I'm going to subtract 5x on both sides. So negative 2y is less than 6 minus 5x. My next step here is I want to get y by itself, so I want to divide negative 2 to everything. Divide this by negative 2, this by negative 2, and this by negative 2. Negative 2 divided by negative 2 is 1, so it's just y. Now, I divided by negative, which means my inequality sign is going to flip the other way. So I'm going to have a greater than now. 6 divided by negative 2 is negative 3. And then negative 5 divided by negative 2 is positive 5 over 2. So the most two common mistakes is 1, we forgot to flip the inequality sign when we divide by negative. And 2, it is right here when we have a negative divided by negative, that's going to be a positive. Okay, so now I have my slope-intercept form. I can identify my slope and my y-intercept. My slope here is positive 5 over 2, and my y-intercept is negative 3. So we have a y-intercept of negative 3, and I'm going to go up 5 to the right 2. 1, 2, 3, 4, 5, right 2. And I can't actually fit any more points on that line. So I'm going to go ahead and draw a dotted line through all of this. And it is dotted because the inequality sign is not equal to. And then it says it is greater than. So I flipped it and now it's greater than. So you want to shade above the line. So it's going to be up here. All right. Now you're like, well, now what? Well, it's asking for a solution and a non-solution. Remember, your solutions are where your two colored parts are overlapping. So I like to do these in two different colors. So if you have pens or if you're using your app or whatever, if you're taking notes, or you should be taking notes, but if you're using two different colors, you can go ahead and see where those two colors are. Usually it's the darker shaded spot. So this spot right here where both of the colors are overlapping, the orange, is where my solutions are located. So I can pick any point as long as it's located in that section. So one of my solutions could be 1, +3, right? 1, +3 lands in there, 1, +3. So that's a solution. But I can also do 1, +5 or 0, 5, right? So 1, 2, 3, 4, 5. So 0, 5 is also a point. So anything in that orange shaded region is a solution. A non-solution is located anywhere else. So for example, 0, 0, since it's not located in that orange, that's a non-solution. Or the point -2, 0, right? So anything outside of that. Or I could do -2, -3. Right? That's also a non-solution. So anything on the outside of that shaded region is a non-solution. All right, 6. Y is less than 2x and y is less than 4. All right, so these are in slope-intercept form already. They just look a little weird. So with this one, we have y is less than 2x. Our slope here is +2 or +2/1. And our y-intercept is 0. So let's go ahead and graph that. So we have a point at 0, 0, and we have up 2 over 1, up 2 over 1, down 2 over -1, down 2 over -1. And this is going to be a dotted line because it's not equal to for our inequality. And it wants us to shade below. So I'm going to go ahead and shade below here. This is below my line. I'm going to do the other line in green. Now this is just y and a number, which means it's going to indicate to me that I'm probably going to have just a solid line, not a solid line, but a straight line either vertically or horizontally. Because it says y, I'm going to be on the y-axis at +4. And I know that this type of line is going to be a horizontal line because that's where my tick marks follow. So I'm going to have a dashed line that goes horizontally. Okay? And then it says y is less than, so I'm going to shade below. Okay, the shaded region where they're overlapping is going to be in this orange area over here. All right, so anything in the orange area is a solution. So I'm going to pick the point 2, 0. That works. Or I could pick the point, let's see, 5, 0. So those are also solutions. So anything in that orange area. A non-solution would be anything on the outside of the orange area. So for example, 0, 2, 0, +2, that's outside, or -3, 0, right? Anything on the outside of that orange shaded part. So it's just like graphing inequalities like earlier, but now you just have two things going on instead of one. All right, I think we have just two left, so that's good. All right, so number 7, x plus y is less than or equal to 3. And then 4x plus 4y is greater than or equal to -4. So I'm going to go ahead and I'm going to get this by itself, y by itself over here. Subtract x on both sides. Y is greater than, or I'm sorry, not greater than. Y is less than or equal to 3 minus x. So my slope here is -1/1, and my y-intercept is +3. So +3 is my y-intercept. And then my slope is -1, so down 1 and then to the right 1, down 1, right 1. And again, I would do as many points as you can. And this is going to be a solid line because there is an equal to symbol here. Okay, and I'm going to shade below because it is less than. All right, on this next one, I'll do this in red. I'm going to get y by itself, so subtract 4x on both sides. 4y is greater than or equal to negative 4 minus 4x. And then I'm going to divide everything by positive 4. Because I'm dividing by a positive number, I do not need to flip my inequality sign here. So y is greater than or equal to negative 1, because negative 4 divided by 4 is negative 1. And then negative 4 divided by 4 is negative 1 again. So I have negative 1x, or just negative x. So my slope here is going to be negative 1 over 1, and my y-intercept is negative 1. So let's go ahead and graph that. We're at negative 1, and we have a slope of negative 1 to the right 1. And this is also going to be a solid line because it is equal to as well. And this one says y is greater than or equal to, so that would shade above the red line here. Now you want to shade from above the red line, not from above the other line, above the line that you just graphed. The mistake that people normally make is that they start shading up here. Okay? You want to start graphing from wherever your line was. So since my red line was down there, I'm going to shade from where my red line started. The area where they're overlapping is in the middle right here, right? Because red and green are both overlapping in the middle. So a solution could be 0, 0, right? 0, 0 is inside there, or 1, 0. A non-solution could be like negative 5, 0, or 0, 10. So 0, 10 would be like all the way up here. Or we could say negative 5, 0, which is located over there in the green. So again, anything on the outside of that orange shaded region. All right, last one. 8. 3y minus x is less than or equal to 9, and x minus 3y is less than 3 times 1 minus y. All right, so number 8. I want to get y by itself, right? So I'm going to go ahead and I'm going to add x to both sides. And then next I'm going to divide everything by 3 because I'm trying to get y by itself. So y is less than or equal to 9 divided by 3 is going to be 3. And then I have 1x divided by 3, so 1 divided by 3, which is positive 1/3 x. My slope here is positive 1/3, and my y-intercept is positive 3. Over here, I got something weird and funky. It's like kind of point-slope form, but not really point-slope form. So the first thing I want to do is I want to get y by itself, but I need to get rid of those parentheses. So I'm going to go ahead and distribute, because it's not even in point-slope form, so that's not very helpful in any way. 3 times 1 is 3. 3 times negative y is negative 3y. Now I want to try to get y by itself. So I need to move all the y's to one side. I like them to be on my left side, so I'm going to move this guy over here. So I'm going to add 3y to both sides. So this would be negative 3 plus 3, which gives me 0. And then I have negative 3 plus 3y, which is also 0. So all I have left is x is less than 3. That's pretty easy. So let's go ahead and graph both of these lines. I'm going to graph the blue line first. I'm going to have a positive 3 y-intercept. And then I go up 1 to the right 3. Up 1 to the right 3. And then I do down 1 to the left 3. So I'm going the opposite way. Now for my blue line, it will be solid because there was an equal to symbol there. And it wants me to shade below because it's less than. All right. Now for purple, I know that's going to be on my x-axis. So I'm going to have at positive 3. Oops, I didn't change it to purple. At positive 3. And I'm going to follow my tick mark. So that's going to be a vertical line, and it's going to be dashed because it does not go through, or it doesn't have an equal to sign. And then it says x is less than 3. So where are all the numbers less than 3? Is it to the left of the number line or to the right of the number line? It's to the left. So we're going to shade on this side over here. All right, so the part where they're both overlapping is where our solutions are located. So in here, we're going to have our solutions. Okay, so one solution could be 0, 0. And I know it's really hard to see, but 0, 0 is right here. So it is located inside there. A non-solution, so I could say 6, 0, right? 1, 2, 3, 4, 5. So 6 zeros right there. Or you could do a 0, positive 6, which is up here. That's outside of your shaded region. So anything outside of that. All right, well, that is graphing systems of equations and inequalities. If you have any questions, please feel free to come in and ask for help.